Hey guys, it's Miss Rupnick here. Today we're here to talk about if a relation is a function. We've talked about relations and functions previously, probably in your previous math classes, but let's make sure we really understand what they are. A relation. So when we talk about a relation between, let's say, two variables, it just means that there's something relating them, right? So there's some rule connecting them. So let's define it as two things related to each other somehow. For example, Taylor Swift and Katy Perry, they're related somehow. Not genetically, I know, but they have a relationship, right? Height and weight, they have a relationship. Your GPA and the amount of hours you study, right? So there are two things that are related to each other somehow. But then we think about functions, right? We think about functions in the math setting. So when we talk about functions, we talk about each input has only one output. Only one output. You might have heard the function analogy to a vending machine before. For example, if I put $1.25 into the vending machine and I pressed, let's say, B6 to get a Sprite, right? If I press B6, I shouldn't get a Sprite and a Coke. I should just get a Sprite. So we can tell things are functions in multiple ways. We can tell it graphically, right? What if we were given a graph? You probably remember from back in the day, the vertical line test, right? How we can tell if something is a function. Now, something that I think maybe you haven't spent a lot of time thinking about is thinking about in terms of y as a function of x, right? I mean, that's generally what we've always thought about as a function, but we're saying here that there's only one y value for every x value. Okay, and that's really what the vertical line test is testing. So what I'd like you guys to do right now is go through these next 6 examples. You have 6 graphs in front of you, and I'd like you to write either yes or no. Is this a function or not? Go ahead, put me on pause, and then we'll check our answers. Okay, so here, the first 3 we had, they were all functions, right? These are all y as a function of x. Again, for every y value, there's exactly one y value for every x value. So for example, even on this quadratic here, right? If I go to 4, even at 4, it has only one y value. Although -4, actually, it's not symmetrical to the y-axis. Let's say about -2, it shares the same y value, but still, there's only one y value for every x. These next 3, hopefully you guys figured out were all no's. Okay, let's take a specific scenario here. Let's look at the x value at 6. Notice that it has more than one y value. Boom, right there. Y is not a function of x. So, what's our conclusion? From these examples, how can you determine from a graph that y is a function of x? And I'd like you to write something here other than the vertical line test. Okay, so take a minute here, and then let's move on. Let's talk about y is a function of x analytically, okay? So I'm actually looking at 4 equations here. Some of them are y is a function of x, and some of them are not. So what I'd like you to do right now is I just want you to think about it and maybe take a guess and put down an answer, yes or no, and then put me on pause. We'll check shortly. Okay, so see if you got the same answers as me. I got 2 yeses, 2 nos. Let's look at the yeses first. What's difficult about these 4 is they're not written as y equals blah, 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 right? you know, they are written in this standard form here. So one thing that I like to do when I'm thinking about y is a function of x analytically is I like to think about, okay, well, what if I solved for y, right? That might be difficult, but what if I did solve for y? Well, in this case, I would have to take a cube root at some point, right? In this particular case, I'd have to take a square root, a fourth root here, and then here I'd have to take a cube root as well. So notice that in both cases when I took the cube root that these were yeses, and in both cases when I took an even root, in this case a square root, this case a fourth root, those were no's. Well, think about it. When I take a square root or I take a fourth root or a sixth root and so on, remember I'm going to have a plus or minus, positive, negative, which produces there to be actually a positive and negative y value for every x value. Hence why these are no's and these are yeses. So, like you guys to take a minute here to write kind of a conclusion talking about what I just said here. Talking about how do we know that y is a function of x? And maybe you can even take that a step further. How would I know if any of these are x as a function of y? So thinking the other way around, what if I had solved for x instead of y? Go ahead, put me on pause, and let's move on. Okay, so last couple of examples for this video here. Now we're given a set of points. Okay, so instead of a graph, instead of an equation, now we're just given ordered pairs. Y is a function of x. And this is the one where I think it's really helpful to think of that vending machine example I was saying, right? I put in a 3, I get out a 4. I put in a 5, I get out a 6. 7, get out a 4. Okay, this is a yes. Here, I put in a 4, I get out a 5. I put in a 6, I get out a 6. I put in a 4, I get out a 6. Wait, what? I thought I put in a 4 and I got out a 5, but here it says I get a 6. Well, okay, not going to work. That is not y as a function of x. I have more than one y value for one x value. All right, so take a minute here, write a conclusion. How can I tell from points, ordered pairs, if y is a function of x? All right, so in conclusion here, a relation with only one output for every input is a function. And you had 3 conclusions that I asked you to write, and I know I didn't answer them for you explicitly, but maybe summarize those 3 conclusions. Summarize what you concluded about y as a function of x. And then maybe think about x as a function of y. Dun, dun, dun.